Hello students, a very warm welcome to BYJU'S Classes. This is Nidhi and today we are going to discuss 26th February second shift mathematics paper which was held this year for JEE Mains conducted by NTA. Well, the next category is numerical answer type. There are 10 questions in this and we have to attempt only 5. Can we find some 5 easy questions which could be attempted? Well, yes, I'll give you more than 5 questions which were on an easier to moderate level. You could have attempted the question very easily. Okay, so coming to the question is saying the total number of 4-digit numbers whose greatest common divisor with 18 is 3. I hope you remember what is greatest common divisor. Greatest common divisor is, suppose if I have a number, let's say 18, what are the different divisors or the factors? Well, the factors are 1, then I have 2, then 3, 6, 9 and 18. These are the different factors or the divisors available. So the greatest divisor has to be 3. And this has to be common with the number, the 4-digit number which they have given to me. So that means that my 4-digit number definitely should be divisible by 3. That is my first condition. And it cannot be divisible by 6 and cannot be divisible by 9. So that means I have to make sure that this 4-digit number is an odd multiple of 3, right? It should not be even multiple, because if it becomes even multiple of 3, 6 will become the greatest common divisor. Clear? So the 4-digit number should be an odd multiple of 3 and definitely not at all divisible by 9. It should not be a multiple of 9. So it has to be an odd multiple of 3 but not divisible by 9. Clear? Okay, perfect. How are we going to solve this out? Well, what we can do is, suppose if I have my 4-digit numbers, what I have to make sure that it has to be an odd multiple of 3 but not a multiple of 9. How many 4-digit numbers actually are possible? Well, there are 9,000 numbers, right? There are total 9,000 numbers which are 4-digit numbers. In these 9,000 numbers, I have some numbers which are written in form of 9 into k. That means a multiple of 9. Then I have some numbers which are written in form of 9k plus 1. Some are in the form of 9k plus 2. Some are in the form of 9k plus 3, 9k plus 4, 9k plus 5, 9k plus 6, 9k plus 7 and 9k plus 8. These are the 9 different categories available with me, right? Now, how many numbers are there of the 9k which are of the 9k form? Well, since all these numbers are equally probable, I can say that each kind of number will be available in thousands, right? First number which is, or let's say the numbers which are of the form of 9k will be 1000. Similarly, the numbers which are of the form 9k plus 1 are again 1000 till the last one. So all these categories have 1000 numbers. So what I have to find is, well, number is not a multiple of 9 but a multiple of 3. So what can I have? Well, if I want to find numbers which are not a multiple of 9, I cannot take 9k. It has to be a multiple of 3. Therefore, 9k plus 1 and 9k plus 2 are not possible because these are not multiple of 3. But I might have 9k plus 3. It is a multiple of 3, not a multiple of 9, right? Definitely 9k plus 4, 9k plus 5 are not at all possible because these numbers are not a multiple of 3. Then I have 9k plus 6 again, which will be a multiple of 3. Then I have 9k plus 7, which is not possible, and 9k plus 8 again not possible. So that gives me 1000 numbers which are of the form 9k plus 3 and 1000 numbers which are of the form 9k plus 6. Total gives me 2000 numbers which are a multiple of 3 but not a multiple of 9. Clear? Now, what have they asked? They have said that number should be an odd multiple of 3. That means if I have 2000 numbers which are multiple of 3, I have to only take which are odd multiple of 3. That means which are odd, right? So out of 2000, how many numbers will be odd? The half of it. So that is going to give me 1000 numbers, which will be odd multiple of 3, but not a multiple of 9. Have you understood? Out of 2000, there will be only 1000 numbers which will be odd multiple of 3 and not a multiple of 9. So the final answer becomes 1000. So the question is this solution. I hope it is clear to you. Have you understood? Perfect. So now the answer is 1000. And the question was not on a difficult side. It was from easy to moderate level. Isn't it? Perfect. Well, this question is saying that if alpha and beta are two real numbers such that their sum is 1 and product is -1, they have defined a sequence P of n is equal to alpha raised to n plus beta raised to n, where P of n minus 1 is 11, P of n plus 1 is 29 for some integer n. What is the value of Pn square? Okay, so I have to find a relation between Pn plus 1 and Pn minus 1 because these values are given to me in the question. That means some relation has to be there. And obviously a relation, or let's say a equation between alpha and beta, or I can say a equation whose roots are alpha and beta, because that again might be used. Okay, so first of all, let's figure out what is the relation between Pn plus 1 and Pn minus 1. Let's do that first. Okay, so my Pn is given to me. So suppose if I write Pn plus 1, this value will be equal to alpha raised to n plus 1 plus beta raised to n plus 1. This is equal to 29. Let me take this as 1. Similarly, if I write Pn minus 1, it will be alpha raised to n minus 1 plus beta raised to n minus 1 is equal to 11. Let me take that as 2. So I have these two equations and I have to somehow find a relation between these two and Pn. So let's see what we can do. Okay, so let's subtract these two equations. When I subtract, I'm writing here 1 minus 2. When I do that, it's going to give me alpha raised to n plus 1 minus alpha raised to n minus 1 plus beta raised to n plus 1 minus beta raised to n minus 1 is equal to 29 minus 11. That is equal to 18. Okay. Now, if I collect from first two terms, if I take common alpha raised to n minus 1, it's going to give me alpha raised to n minus 1 multiplied by alpha square minus 1 plus again beta raised to n minus 1 multiplied by beta square minus 1 is equal to 18. That means I'm getting same kind of expression in alpha as well as in beta. Now what? Well, now let's go to the relation of alpha and beta which they have mentioned to us. Okay, so my alpha plus beta value is 1 and my alpha beta value is minus 1. So what I'll do, I'll put my beta value in the second equation. When I do that, it's going to become alpha multiplied by 1 minus alpha is equal to minus 1. Or from here, I can say that alpha is equal to alpha square minus 1. This is the relation. That means I can also say that my beta will become equal to beta square minus 1. Because alpha and beta will be roots of the equation x square minus x minus 1 is equal to 0. Right? They'll have the same relation. And now we have arrived at the relation what we wanted. I already have my terms of alpha square minus 1 and beta square minus 1. So when I substitute alpha square minus 1 as alpha over here, it's going to become alpha raised to n minus 1 multiplied by alpha. Similarly, I'll have the next relation as, or the next term as, beta raised to n minus 1 multiplied by, in place of beta square minus 1, I can again write beta, right? So it's going to become beta is equal to 18. Finally, it is alpha raised to n plus beta raised to n is equal to 18. And bingo, we have got what we wanted. This is equal to Pn, isn't it? This is what they have mentioned in the question. And what have they asked us? Pn square value. So I'll just square. So that means my Pn square value is 18 square. can be written as equal to 324. This is going to be the final answer. Question was interesting, isn't it? We have to manipulate some terms. We have to actually find a relation between Pn plus 1, Pn minus 1 and Pn. And also a relation between alpha and beta, or let's say a quadratic whose roots will be alpha and beta. Right? So I would say the question was a bit interesting. Definitely not on the easier side. You have to work out some terms to get the value of Pn. Understood? So the answer for the question is 324. The next question is from statistics. They have said that x1 to x18 be the 18 observations such that summation of xi minus alpha from I is equal to 1 to 18 is equal to 36, and summation of I is equal to 1 to 18 xi minus beta whole square is 90, where alpha and beta are distinct real numbers. Further, they have said that standard deviation, if that is 1, what is the value of modulus of alpha minus beta? Okay. So I have to use formula for standard deviation, right? They have mentioned us two things. Summation of xi minus alpha is given and xi minus beta whole square is also given. So first of all, what is standard deviation formula? That we have to recall. So my sigma value is nothing but root over summation xi whole square by n. In this case, that is 18 minus summation of xi by 18, which is nothing but my mean, or x bar whole square. This is the formula. So if I have to use this formula because my standard deviation is given to me as 1, that means what can I say is that I have to find summation of xi square value as well as summation of xi value. And these can be found out using the two relations which they have mentioned in the question. Okay, from there we might get a relation where I can get the value of alpha minus beta positive difference. Clear? Okay, so what we have thought just now, that we have to find summation of xi square as well as summation of xi first using these two relations. So what I'll do in the first relation, I can separate this out. It's summation of xi minus summation of alpha. Well, alpha is a constant term, right? So if I add alpha 18 times, it's going to give me 18 alpha. This is equal to 36. That means I can say that my summation xi will be 18 times of alpha plus 2. Clear? Okay. Then I have one more relation, summation xi minus beta whole square. So when I expand this out, it's going to become summation of xi square plus summation of beta square minus twice summation of xi beta is equal to 90. Again, what I can do is my summation of beta square is a constant. So that if I add 18 times, it's going to give me summation of xi square plus 18 times of beta square minus 2 beta times of summation xi is equal to 90. So from here, I can definitely say that my summation of xi square value will become 90 minus 18 beta square plus 2 beta times summation of xi. And what can I substitute in place of summation of xi? We have just found out it's 18 times of alpha plus 2. So here this can be written as multiplied by 18 times of alpha plus 2. Clear? Now I'm going to use the formula for standard deviation. So when I substitute the values here, it's going to give me 1 is equal to, my sigma square is variance. So that value again is 1. It's a square of standard deviation, right? So 1 is equal to summation of xi square by 18. So summation of xi square value we have just found out. So it's going to become 90 minus 18 beta square plus twice of 18 multiplied by beta times of alpha plus 2 whole divided by 18 minus summation of xi by 18. So my summation of xi is 18 times of alpha plus 2, isn't it? So when I divide this quantity by 18, it's going to give me only alpha plus 2 whole square. So from here, what I can do is, I'm going to cancel first of all this 18 from here. and this will be 5. So I will be left with 1 is equal to 5 minus beta square plus 2 beta alpha plus 4 beta minus alpha square minus 4 alpha minus 4. So let's see, are we getting some terms? Well, I have 5, 1 and 4 getting cancelled out. Then I have alpha square, beta square, 2 alpha beta. So I'm taking this term on to my left side. So it's going to become alpha square plus beta square minus 2 alpha beta, which will be nothing but alpha minus beta whole square, right? And what are the leftover terms? The leftover terms are 4 beta, 4 alpha. When I take again to the left hand side, it's 4 times of alpha minus beta is equal to 0. So from here, I can say that alpha minus beta values will be either 0 or minus 4. But since alpha and beta were distinct, alpha minus beta cannot be equal to 0. So the value is minus 4. And in question, what have they asked? Well, they have asked us that modulus of alpha minus beta is equal to what? So the answer will be 4. This will be the value of modulus of alpha minus beta. Have you understood? This was a question from statistics, and what we have learned is that I have to solve for summation of xi square and summation of xi, then put in the standard deviation or variance formula and solve for alpha minus beta. Clear? Have you understood, guys? Perfect. So the answer is 4. Well, the next question is from definite integration, and it was on a difficult level. I totally agree with that. As a student's perspective or from a student's perspective, I would definitely leave this question while attempting the paper. But from a teacher's point of view, I actually really enjoyed the question. It happens very rare that JEE Mains actually ask these kind of questions. I was totally impressed by the team who has prepared the paper. Okay, so the paper was from definite integration. Let's read the question, what the question is saying. It's saying that if I am in, my integral is from 0 to 1, x raised to m minus 1 multiplied by 1 minus x raised to n minus 1 dx. For mn greater than equal to 1, I have one more integral, that is 0 to 1 x raised to m plus 1 plus x raised to x raised to m minus 1 plus x raised to n minus 1 divided by 1 plus x raised to m plus n dx. This is equal to alpha times of Imn. That means what they want is, they want this integral I to be expressed in terms of Imn such that you get a constant alpha in front, and what have they asked is the value of alpha. How are we going to solve this question? Well, one way is we can substitute some values of m and n, right? And then compare both sides and get the value of alpha. That is one way. We can put m and n both as 1. So when I do that, my I11 will be equal to, when I put m and n both as 1, it's 0 to 1 dx, which is nothing but x from 0 to 1, that is 1. And in my I, if I do the same trick, it's I is equal to, I'll get 0 to 1, m minus 1 will be 0, so x raised to 0 is 1. So I'm going to get 2 divided by 1 plus x whole square. Well, you know what is the integration of this, right? It's minus 2 divided by 1 plus x. When I substitute the value 0 and 1, it's going to give me minus 2 by 2. And then I'll have minus 2 by 1. So this value will come out as 1. That means my I is 1. My Imn, or in this case I1 comma 1 is again 1. So that has to give the alpha value as 1. A simple solution. Enjoyed it? I hope you have done it. You have enjoyed it. This was the simplest way to solve this question. Just put some values of m and n, and it was very simple. They have given us equality when m and n both are equal to 1. Substitute it, get the answer. Alpha has to be 1 because it is true for all values of m and n. Clear? This is the answer. But suppose if you want that, ma'am, how should we solve this question? That is that is a lengthier approach. And you have to think also what kind of substitution in I. You have to substitute x in terms of some another variable such that I actually transforms to a term somewhat similar to I mn. Well, let's see how do we do that also. So here I am going to substitute x as y upon 1 minus y. Why am I doing that? Because see, in denominator I have 1 plus x. What I want is, I want to create this 1 plus x as 1. That means I want to eliminate the denominator part and want to bring all the terms in numerator. So when I substitute x as y upon 1 minus y, my 1 plus x value will become 1 plus y upon 1 minus y. That is 1 upon 1 minus y. And 1 minus y can be taken in numerator, right? So that was the hint over here. Okay, so when my x value is y upon 1 minus y, my dx will be definitely 1 minus y times of minus 1 divided by 1 minus y whole square. It is 1 minus y plus y upon 1 minus y whole square dy. Right? So my dx actually is coming out as 1 upon 1 minus y whole square dy. Understood? Perfect. So this is the substitution I'm using over here. Now let's substitute and check what do we get. So we are solving for I, right? So I can say that my I value now will become, first of all, I have to put the limit. So if my x is 0 over here, my y value will again be 0. So my lower limit of y is 0. But suppose if I take my x as the upper limit, which is 1, I'm going to get 1 is equal to y upon 1 minus y. That means y value is half, right? So the upper limit is 1 by 2. Clear? Perfect. What are the terms? Well, x raised to m minus 1 will be y raised to m minus 1 divided by 1 minus y raised to m minus 1. Then I'll have y raised to n minus 1 divided by 1 minus y raised to n minus 1 whole divided by, we have just seen that 1 plus x is going to become 1 upon 1 minus y. So I'll take 1 minus y in numerator. Here it is 1 and it's going to become multiplied by 1 minus y raised to m plus n multiplied by dx. That is 1 minus y whole square times of dy. Understood? Perfect. So my I definitely will therefore become 0 to half. Now I'm multiplying the terms. So I'll get y raised to m minus 1 multiplied by 1 minus y raised to m plus n, 1 minus y raised to m minus 1 and 1 minus y whole square in denominator. When I combine totally, it's going to give me 1 minus y raised to m plus n minus m minus 1 minus 2. What this value is coming out as? Well, it's becoming n minus 1, right? Okay, so this is equal to n minus 1. Plus, I'll have one more term, which will be y raised to n minus 1. And again, I'll combine 1 minus y raised to n minus 1 in the denominator part with 1 minus y raised to m plus n in the numerator. So it's m plus n minus 1 minus 2, right? And this actually comes out as nothing but m minus 1 dy. What have I got? Well, these are some similar kind of expressions, right? Only the powers are changing. In place of m minus 1 over here, I have n minus 1 and vice versa for the second part. So what should we do? Well, now can I get it directly in terms of I mn? So I have to anyhow relate my I and I mn. My I mn has the upper limit as 1 while my I as upper limit has as half. So what am I going to do is, I'm not touching my I for time being. I will actually try to simplify my I mn. So my I mn is given to me as 0 to 1. X raised to m minus 1, 1 minus x raised to n minus 1 dx. What I'll do here is, if I put x as 1 minus x, if I do that, if I put my x as 1 minus x, I'm going to use a property over here. What is that property? Let's quickly see. So till here, this was I. We have got I as 0 to half, y raised to m minus 1, 1 minus y raised to n minus 1, plus y raised to n minus 1, 1 minus y raised to m minus 1 dy. And now we are actually changing IMN. So IMN limit is from 0 to 1. This 1 can be written as twice of 1 by 2. So now I'm using the property that 0 to 2a fx dx can be written as 0 to a fx plus f of 2a minus x. Right? This is the property which I hope you have learned. I know you have learned. I hope you remember that 0 to a fx dx can be written like this. So if I change my mn using this property, it's going to become 0 to a, that is 0 to half. Fx is x raised to m minus 1 multiplied by 1 minus x raised to n minus 1 plus, when I put x as 1 minus x, it's going to become 1 minus x raised to m minus 1 multiplied by x raised to n minus 1 dx. Clear? And now guys, if you actually look at I and IMN, the expressions are actually same, just the variable is changing. And if we change the variable, the integral is same, right? That means I can therefore say that my IMN and I both are equal. So therefore, if I is equal to alpha times of IMN is what they have mentioned, I can clearly say that my alpha value is 1. This we have already got when we substituted the values of m and n. Remember the first way, which was easier one, isn't it? Okay, so my alpha value will be 1. The final answer is 1. Well, the next question is a combination of conics, that is ellipse and circle. And to solve this question, again, you have to remember some formulas. What the question is saying is, let L be a common tangent to the curves. First is an ellipse, which can be written in its general or in its standard form as x square by 9 plus y square by 4 is equal to 1. And next one is nothing but a circle, which is x square plus y square is equal to 31 by 4. So I have to find common tangent to these two curves. Further, they have said what is the square of slope of the line L, which is the common tangent. So I have to find the value of m square. Okay. Now, question was not difficult. It was from easy to moderate side. Given, you remember the equation of tangents to both the curves. And that too in slope form. Why in slope form? Because they have asked the slope value. That means if I directly use the slope form, I can actually directly get the value of m square. Okay, so moving on to the solution part, we have a circle and an ellipse. So first of all, let's write the equation of tangent to the ellipse. If I have my ellipse in standard form, that is x square by a square plus y square by b square is equal to 1. What is the equation of tangent in slope form? Well, it is equal to y is equal to mx plus minus. Can you recall what was that? It's nothing but root over a square m square plus b square, right? So when I substitute the values, it's going to become root over 9m square plus 4. This is going to be the constant term. Okay, coming to the circle part. Well, my circle is pretty standard one. Its center again is nothing but 0, 0. So if I want to write the equation of tangent in slope form to the circle, if I have my circle as x square plus y square is equal to a square, the equation is nothing but y is equal to mx plus minus a root over 1 plus m square. Right? Okay, a is the radius over here. So when I substitute for the circle and put the values, the equation will somewhat come like this. My radius or a value is root over 31 by 4. And now what we are going to do? Well, since the equations are same because they are talking about the common tangent, we'll just equate the constant term, right? Y is equal to mx part is same for both. We'll just equate the constant term. That's it. This was what you have to do here. So when I equate the constant term, I'm going to get 9m square plus 4 is equal to 31 by 4 m square plus 31 by 4. I've done the squaring both sides. So it's going to give me 9m square minus 31 by 4 m square is equal to 31 by 4 minus 4. So on my left hand side, it's going to become 5m square by 4. While on my right hand side, it's 31 minus 16, that is 15 by 4. And from here, m square value is coming out as 3, which is going to be the final answer. The question was on easy to moderate level. You could have done the question if you remember the formulas. Again, emphasizing on the fact that, guys, please revise the formula and be ready for the next exams to come. Perfect. Have you understood the solution? Very well. So the answer is 3.